Hi everyone, welcome to Calculus and Vectors. Today we're going to do 1.3 rate of change. Our learning goal today is to find average and instantaneous rate of change. So first, we need to understand what is a rate of change. So rate of change, ROC, is considered like slope, steepness, change in y over change in x. There's two different categories, average and instantaneous rate of change. Okay. Now, average rate of change is rise over run, which is exactly the same as a slope. And you can represent it using a function notation or y2 minus y1, x2 minus x1. Keep in mind that the average rate of change is same as the slope of the secant line, meaning you are finding the slope, the steepness, using 2 points. If you're given x as a, then the second point, x2, will be a plus h. So let's try an example, number 1. Consider f at x equals x plus 1 squared. Find the rate of change over the interval. Now, the tricky part here is this -1, 2, it's not xy. It says interval. What that means is that x, it belongs to, using the interval notation, -1 and 2. So that means x is in between -1 and 2. That is the interval notation. So we could say when x1 is -1, y1, meaning we're going to input x1, which is -1, into my given function, which is -1 plus 1 squared is equal to 0. Then x2, my second point, my y2 is going to be, I'm going to plug in my input x2, which is f at 2, into my given function, which is 2 plus 1 squared is equal to 9. That's it. So average rate of change is equal to y2 minus y1, x2 minus x1. Then you plug it in. So 9 minus 0, 2 minus -1, and that will give me 3. So that is the slope of a secant line, or average rate of change. So we didn't have to use this formula because the 2 points are given. Specifically, it's the average velocity. So we represent average velocity with AV, given the interval of the x value. Well, in this case, it will be time. So for velocity to find the steepness, it will be speed over time. Okay, now keep in mind the unit for velocity is meter per second. Example 2. So a rock is launched vertically upward. The height of the rock is given by this, and they're saying find the average velocity given the interval 1, 2. Same thing. So it's the function is in terms of t. So t1 is 1. So let's plug in s when t1, which is s, the speed when the input is 1. So what I'm going to do is I'm going to plug in 1 into the function s, minus 10, 1 squared, and it will give me 90 meter. Now t2, on the other hand, is 2. So speed when my input is 2, which is the height, is equal to 100, 2 minus 10, 2 squared. You simplify that and you will get 160 meters. So therefore, to find the average velocity, AV, is equal to S2 minus S1, T2 minus T1. So there's not much space. I will go horizontally. It's going to be 160 minus 90 over 2 minus 1. And that will give me 70 over 1, so which is 70. So therefore, average velocity is 70 meter per second. Now moving on to instantaneous rate of change. So instantaneous rate of change is actually the same as finding the slope of a tangent line, meaning finding the slope of a one point that is on the curve. So if that's the case, we need to make sure that the h is approaching 0. Very, very, very minimal, meaning just like almost approaching 0. And we represent it with IRC, instantaneous rate of change. So I interchange between IRC or IROC. They're exactly the same, okay? So then it's the same formula for the reaction quotient from the previous chapter, from the previous section. And so if we are given a specific point, A at F at A, then you could plug it into a speed function if you are looking for instantaneous velocity. Okay. So overall, we're pretty much finding the limiting value of average velocity as h approaching 0. So consider the following position function, and they're saying find the instantaneous velocity at t equals 3 seconds. So as always, for instantaneous, let's figure out what a is. A is 3. So that means my output when it's 3 seconds. So I'm going to plug in 3 into my given function, which is t squared minus 4t. So 3 squared minus 4, 3. And you simplify that and you will get negative 3. Then we need to figure out what speed a plus h. Now we know what a is going to be. So s 3 plus h. Again, we are going to plug this input into my given function. So it's going to be 3 plus h squared minus 4, 3 plus h. Okay, so I will simplify 9, 6h plus h squared. So using FOIL, 12 minus 4h. Collect the like terms. It's going to be, these are the like terms. So h squared plus 2h minus 3. Okay, let's write down the formula. So instantaneous velocity, or you could write it as IROC. It's exactly the same thing, is limit h approaches 0, f at a plus h minus f at a over h. We know limit. So we're going to plug in a, which is 3 plus h, minus f at 3 equals h. Now, my apologies. So its speed s, the function position. So instead of writing f, you should be writing s according to the given question. So limit h approaching 0. So let's plug in what my output is going to be. So my output for this one is this: h squared plus 2h minus 3. And my output for s at 3 is going to be negative 3 over h. And you will notice that negative 3 and this becomes positive 3, right? So it will cancel. Okay, so limit h approaching 0, h squared plus 2h over h. Now you will notice that the expression both contain h, so we can simplify. Limit h approaching 0, h plus 2. Now that I've canceled out h, we can plug in h, a 0. So I'm no longer writing limit. It's going to be 0 plus 2, which is 2. So therefore, my instantaneous velocity is going to be 2 meters per second. So number 4, a spherical balloon is inflated. Find the instantaneous rate of change in volume with respect to radius when radius is 10. So this is very similar to finding instantaneous rate of change. It's just that it's not velocity, instead it's volume. So we have to identify what A is. In this case, the radius. A is 10. And let's figure out my output. So volume, what's my volume going to be when it's 10? So it's going to be 4 pi 10 cubic over 3. And we also need to figure out what my A plus H. So A is 10 plus H. So we're going to plug this into my R, my input. So 4 pi 10 plus H cubic over 3. So I'm not going to simplify yet, so I will show you why. So instantaneous rate of change is equal to limit h approaching 0, volume 10 plus h, minus volume at 10, my radius, over h. So I'm going to input my volume so this is equal to this over here, my output. So 4 pi over 3, 10 plus h cubic, minus 4 pi 10 cubic over 3, and then divided by h. So I put it on the side due to space. Now keep in mind, if you take a look closely, that we have a common factor, 4 pi over 3 for both of them. So I'm going to factor 4 pi over 3. So when you factor it out, it goes right in front of the limit. So 4 pi over 3, limit h approaches 0, it's going to be 10 plus h cubic minus 10 cubic. Okay, I'll put, and then divided by h. So what we can do is you can expand it, or do you notice that it's a difference of cubes? So difference of cube is a cube minus b cube. The formula is a minus b. It's going to be a squared plus 2ab plus b squared. So this is a difference of cubes, which you have to memorize. So I'm going to factor it by using this method. So 4 pi over 3, limit h approaching 0. So A is 10 plus h, and B is 10. So let's start. A is 10 plus h minus B, which is 10. That's my first bracket. And then in the second bracket, A squared. So it's 10 plus h squared. Don't forget the bracket. And then plus 2ab. So plus 2. A is 10 plus h. And B is 10. And then plus b squared. So plus 10 squared. And close the bracket divided by h. Now, so 10 and negative 10, it cancels out. And you're left with h. So this pretty much means it becomes h bracket this whole thing divided by h. So you can cancel additionally because we have h in the numerator and denominator. Cancel, cancel. So we finally canceled out h in the denominator, so we can actually plug in the limit value. So it's going to be 4 pi over 3. So I'm not going to write limit. Why? Because I'm going to plug in h as 0. So 10 plus 0 squared plus 2, 10 plus 0, and then 10, and then plus 10 squared. So do you see that? So it worked out really well because h was able to cancel out. So you're going to do the math of 10 squared. So it's going to be 4 pi over 3, and then do the bed mass and times this. So you should be getting, I'm going to leave it as pi altogether. It should give you 400 pi. So leave it as an exact answer. And the volume is going to be meter. Because it's the slope of the volume, so it should be m squared. So that is the instantaneous rate of change. Okay, and that's it.